Now we shall consider a simple circuit. It has a voltage source and two resistors are connected in parallel with the voltage source. Using oscilloscope, we shall display the source voltage and also the voltages across the resistors R1 and R2. So here is the circuit. We have set up the circuit here. Two resistors, they are connected in series with the voltage source, that is the signal generator output. So the oscilloscope, it has two channels, channel 1 and channel 2. So the channel 1 is connected to the signal generator. So channel 1 is displaying the source voltage, and channel 2, we have connected channel 2 across R2. So channel 2 is measuring the voltage across the resistance R2. Now the oscilloscope have two channels, channel 1 and channel 2, but we also have math function. Using math function, we can do a number of mathematical operations. So we can add two channels, we can subtract two channels, we can multiply two channels. By two channels I mean the voltages of the two channels, and we can also do things like integration and differentiation. So in this case what we shall do is, we have source voltage on channel 1 and VR2 on channel 2. So if we subtract channel 2 from channel 1, then we shall get the voltage across R1. So we have activated the math function and we have selected 1 minus 2, that is channel 1 minus channel 2, that is the voltage in channel 1 minus the voltage in channel 2. So we see a third waveform, but when math is not activated, we see only channel 1 and channel 2. But when we select math, and then it displays whatever the function is set. But one important thing is, the channel 1, the volts per division setting is 2 volts per division. For channel 2, the volts per division setting is 2 volts per division. That is, for channel 2, each measured division equals 2 volts, and for channel 1, each measured division also equals 2 volts. And you can change them, but actually we should set such a scale that the waveforms are fitted into the display. Now math, we also need to check the settings for this math channel. So here the scale is 2 volts. We can change the scale 1 volt, and as I change the scale, we see the amplitude swing increases. Actually the voltage remains the same, but because we choose to use a smaller scale, we see a larger voltage swing, and offset is 0. So to measure how much is the actual voltage, we need to check the scale, and we should set the offset to 0 unless we want to add any offset to that voltage waveform. And we can also use this time per division button to select the time scale, that is how many cycles we want to display. Now the time scale setting is 500 microseconds per division. So one measured division equals 500 microseconds. We should set it in such a way that at least we can see a couple of waveforms on the display.